All right, we just want to answer one question today, and that one question is how many grams of MgCl2 will be produced from 16 grams of MgOH2 and 11 grams of HCl? Now those will be magnesium chloride, magnesium hydroxide, and hydrochloric acid. And then once we figure that out, we want to know how much excess reagent is left over. So the first thing that we're going to need to do is find our molar masses. And if we're starting with our 16 grams of magnesium hydroxide, we need this molar mass, or these atomic masses added up from the periodic table. So if we go and we look up magnesium, we'll find that magnesium is going to be about 24.31 grams, and then we're going to have to add to that 16 times 2 for our oxygen, plus 1.01 for hydrogen, times 2 as well, because we want to distribute those inside the parentheses, that 2 there. If we add this all up, we are going to get 26, no, we are not going to get that. We're going to get 58.33 grams per mole for MgOH2. All right. And while we're at it, let's also calculate our molar masses for HCl and for MgCl2, because we're going to need those as well. So we've got 1.01 here for hydrogen, plus 35.45 for chlorine. And if we add those up, that's going to give us 36.46 grams per mole. And then for MgCl2, we'll do that over here. That's going to be, again, 24.31 plus, let's see, we've got chlorine times 2, 35.45 times 2. All right, and if we add that up, that's going to give us 95.21 gram. Oh, hey, I can't write over there. 95.21 grams per mole. Okay, so we have our 3 different molar masses for our 3 compounds. Now we need to figure out if we have 16 grams of our MgOH2, so 16.0 grams MgOH2, how much MgCl2 is that going to give us? How much magnesium chloride will that give us? So we want our grams to cancel out, so that's going to be over here on the bottom, our molar mass of magnesium hydroxide, which is our 58.33 grams, and that's going to be in 1 mole. And remember, this is our MgOH2, and we should include our units for both sides of this. We should include our units in the numerator and the denominator, so MgOH2 down here as well. Next, we need to do our conversion step, and this is where we look at the coefficients in our balanced chemical equation. And if we're going from magnesium hydroxide to magnesium chloride, we see that there's no coefficients in front of either one of those formulas, which means we have 1 mole of each. And so we want our 1 mole of MgCl2 on the top, and we want our 1 mole of MgOH2 on the bottom. This allows these units to cancel out here. Our grams and our grams have canceled out, and now we're left with moles of magnesium chloride. And we want to get from moles of magnesium chloride into grams of magnesium chloride, so that's where our next molar mass is going to come into play. We've got our 1 mole MgCl2 down here, and then we have the molar mass of that up top, which is, if we look over here, was our 95.21 grams. All right, our units cancel out. We plug this into our calculator, and this was MgCl2. Okay, plug that into our calculator, and we end up with an answer of 26.1 grams of MgCl2 can possibly be produced if this reaction went to completion, if we used up all 16 grams of our magnesium chloride. Now, we don't know if we're going to use all of that up because we still have to figure out how much of our 11 grams will be used up of our hydrochloric acid here. So we have 2 different things that are going to be disappearing, and we want to find out which one of these is going to run out first. And when one of them runs out, that stops our reaction because we don't have any more of it left. We have nothing left to react when it runs out. So let's figure out here our HCl. We've got 11 grams of hydrochloric acid, and that is going to react, and it's gonna form our magnesium chloride as well. And so we need to convert again to the same thing like we just did, but we need a different molar mass down here. We need our 36.46. Oops, 36.46 grams in 1 mole of our hydrochloric acid. And then we're going to convert again using these coefficients. Now this time we have a 2 here in front of our HCl, which means we need 2 moles of HCl down here on the bottom. And again, we have no coefficient in front of our magnesium chloride, so it's just 1 mole of MgCl2. All of our units are canceling out so far, so we're good. And now we just need the same exact last step that we had up here. So let's go ahead, write in our 95.21 grams MgCl2 and our 1 mole of MgCl2. All right. Plug this one into our calculator, and we should end up with an answer of about 14.46 or 14.5 grams of MgCl2. All right, so we have our 14.4 or 14.5 grams of MgCl2, and now we need to answer that first question. How many grams of magnesium chloride are produced from these two starting amounts? And you always want to pick this lower amount here. 14.5 grams can be produced because our hydrochloric acid, once this much magnesium chloride is produced, that means our hydrochloric acid has run out. We have no more left to use up, so we can't produce any more than 14.5 grams of magnesium chloride given the two starting amounts that we have. So this is how much we can produce. Okay, and if we wanted to answer a different question, that would mean this is what we call our limiting reactant or limiting reagent. And this guy up here, our magnesium hydroxide, this would be our excess reactant. Now, to figure out the second part of the question, how much excess reagent is left over, we've got 2 more final steps. We need to take how much of our magnesium chloride is produced, and we want to figure out then, if we work backwards from this 14.5 grams, how much are we using up of our magnesium hydroxide, because that was our excess. So we want to set up another problem down here, our 14.5 grams of MgCl2. And we're going to work backwards now to our magnesium hydroxide to figure out how much did we use to produce 14.5 grams of magnesium chloride. So we need our molar mass of magnesium chloride down here, which is our 95.21 grams in 1 mole. All right. And then we need to convert back using our coefficients into magnesium hydroxide. So our magnesium hydroxide was 1 mole MgOH2. And then we also had 1 mole of MgCl2. All right. And our final step now is converting into our grams of magnesium hydroxide. So we need its molar mass again. So we have 1 mole down here on the bottom, and then our molar mass of 58.33 grams. When we plug this into our calculator, we get about 8.82 grams of magnesium hydroxide, MgOH2, and this is how much magnesium hydroxide was used up. So be careful here. This is not what the second part of our question is asking for. It's asking us for how much excess reagent is left over. So we want to know, of those 16 grams that we started with, how much did we have left? Well, if we used up this much, we find our total, or we start with our total of 16.0, and we're going to subtract our 8.82 because that's how much we used. And then we're going to end up with how much we have left over. And so that's going to be 7.2 grams of magnesium hydroxide left. And so that's our final answer right down here. All right. Hope you guys found this video helpful. Let me know if you have any questions. I'll see you guys in class tomorrow.